Welcome, Sprout Like Nation, to another glorious day here in Chattanooga, Tennessee. I got my buddy Brent here. We're always going to talk about concrete as we are so like to do, since we kind of fell in love with it many years ago. Today we want to talk about the importance of your water to cementitious ratio. Or, for those outside the United States, sometimes it is the water to binder ratio.
Yep.
And Brent, really wanted you to kind of talk about this. In your days of the ready mix, this was an important thing for you.
Oh yeah, definitely. So it really all goes back to ancient times. They probably discovered this, but we give credit to
Ancient times?
yes,
Like
Romans,
3 hours ago?
Yeah, like Roman concrete. But in recent years, in modern concrete era,
Roman concrete? Like concrete that just moved around?
No, back in Rome, like we're talking about, the Caesars and legionaries and all that stuff. Okay. In the early 1900s, a guy by the name of Duff Abrams was doing a lot of concrete research, and he made the discovery, if you will, rediscovered that the more water you add to concrete in general, the weaker that concrete would become and the less durable that concrete would become. And he called this, or others called it for him, Abrams' Law. And that was 1918, I believe, maybe, or 1912. I can't remember. It's one of those even-numbered years in the teens, before the Depression. That's one of those. Anyway, that's how I organize thoughts in my brain. Yeah, so Duff Abrams discovered this, and many years later, it still pretty much holds true. If you have lower water, then your concrete's stronger in general, and you have more water, then your concrete's weaker.
On conventional concrete.
On conventional concrete, yeah. There are special
things you
cases.
Can do yes, but for the most part, it is a good rule to go by.
Yeah. And for years before we really started getting into the chemical admixtures and pozzolans and things that we have, supplementary cementitious materials that we have today, for years that water to cement ratio that you needed to get water to cementitious ratio, you needed to get strength, would also provide durability.
Right.
And since about the 1970s or so, we've really improved the way we can gain strength at early ages.
Right.
We're able to use less cementitious material, and more water, and still get the strengths we're looking for. Yeah, so basically the way that you calculate water to cementitious ratios, you take the
Pounds of water.
And
that's where I'd start.
Yeah, I was struggling with, I was going pounds, kilograms. Yeah.
Or whatever unit of measure you're using to it, just
mass or weight of the water per cubic meter or cubic yard, here in this country, cubic yard. And you divide that by your total cementitious content in pounds or kilograms. Don't switch the units between water and cementitious.
And that is your cement, that is your pozzolans.
Yeah, your supplementaries, your ashes and other things. So you get your water to cementitious ratio, and from that you can have some general idea of how the concrete's going to behave from the ACI tables and other places. So that's a good starting point in general. Remember, higher water to cement ratio is, the lower the strength's going to be. What's a water to cement ratio or cementitious ratio you see a lot, Josh?
Usually 0.42.
0.42?
0.45, depending on what structure you're doing. A lot of it's going to be in the design or the submittal package from the concrete producer as to what he's going to try to hit, and so you're trying to make sure you're staying within that realm and that that's submitted for.
So it's important.
Very much important.
Yep. So thank you for joining us today. The water to cementitious ratio is not a difficult calculation to make, but it's one that not a lot of people outside the world of concrete techs know. So we wanted to share that with you today. And please be sure to comment, hit like, subscribe, and put your questions down below, and we'll get to them.
Appreciate it. Thank you.
Thank you.